Okay, guys, so here's some review. Back in the B cycle, we did the intermediate value theorem. And I just want you to be able to see the similarities and differences between the intermediate value theorem and the mean value theorem, because you're going to have to use both. You're going to have to be able to recognize both and then also use both to explain why certain values exist. Okay, so this was back in B11. The directions were that given that f is continuous on the closed interval -3, 7 and the table of values below, explain why there exists a value c between -3 and 7 for which f of c equals -3. So not f prime. If it were f prime of c, then we'd be looking at the mean value theorem, which would also require us to be told that f is differentiable on the open interval. But so we know this is the intermediate value theorem. Now, guys, the problem is, though, if you look at the outputs of 0 at -3 and 7, the outputs there are 0 and 4. -3 is not an intermediate value for 0 and 4. It's not between them. So I said here, since -3 is not between f of -3 and f of 7, we need to use a subinterval. And then we noticed that the subinterval 1, 4 would work. Because look at f of 1 and f of 4. They're 1 and -5. -3 is between 1 and -5. So that's the subinterval that we're going to use. So you go f of 1 is 1. F of 4 is -5. So that's the subinterval we're using, -1 to 4. And -3 is an intermediate value. Since f is continuous on -3, 7, that's what we were told. So we have to bring in what we were given. Since f is continuous on -3, 7, it is also continuous on the subinterval 1, 4. So I'm going to use the intermediate value theorem on 1, 4, and then at the end I'm going to say, then at the end I'll bring in the full interval -3, 7. So it's also continuous on the closed interval 1, 4. Therefore, by the intermediate value theorem, there exists a c between 1 and 4 for which f of c is -3. Okay, now remember, I already mentioned that the closed interval 1, 4 is a subinterval of the closed interval -3, 7. So now I can say, thus, there exists a value c between -3 and 7 for which f of c equals -3. Okay, so we're going to do something similar using a subinterval and the mean value theorem. So I won't read this for you guys, but here's the explanation using the intermediate value theorem in a subinterval. The preliminary information would be that f is continuous on AB, and you could see from either a table or a graph that DE is a subinterval of AB. So it would look something like this. So here's the full interval AB, and then DE is a subinterval. Guys, sometimes a subinterval includes one of the original endpoints of the big one. So in this case, AD is a subinterval of AB. Okay, now explanation using the mean value theorem in a subinterval. So here's the preliminary information. You would need to know that f is continuous on the closed interval AB and differentiable on the open interval AB. And you could see that DE is a subinterval. Okay, then the explanation would go like this. Okay, I'm not going to read it to you. Please go back and read it yourself after you see the example that I'm about to do. Okay, so, and you just have to do one of these, all right, for the practice. So you're given that H is continuous on 0 to 9, closed, meaning it includes the endpoints, and differentiable on 0 to 9, open, meaning it doesn't include the endpoints. Use the mean value theorem to explain why there exists a value c between 0 and 9 for which f prime or h prime of c equals 5/2. Now, guys, in the future, they're not going to say to you necessarily which theorem to use. So the clue that you would need to use the mean value theorem is that you're proving that the derivative equals a certain value. All right, if you were trying to show that just the function, not the derivative, equals a certain value, that would be the intermediate value theorem. Okay, so let me do some side work. Okay, so aside. All right, so since they want you to prove that this C exists between 0 and 9, let me just do the slope of the secant line, or the average rate of change on the whole interval and see what happens. I'm wrong. 9 minus 0, whoopsie. Okay, f of 9 is 5. F of 0 is -4. And then 9 minus 0 is 9. That's 9 over 9. That's 1. Guys, that's not 5/2. Okay? So I need to find a subinterval, so a smaller interval inside here, that has an average rate of change of 5/2. Okay? Need to find subinterval with this average rate of change. Okay? Now it might take you a little bit to find it, but let me see, what is it? 5/2. Let me think. -8. No. Oh, good. Thank goodness. Okay, it's this one. I thought for a minute I messed up. So this would be the subinterval, I think. All right, so let's try the interval 7 to 9. All right, so let me do the average rate of change on 7 to 9. So f of 9 minus f of 7 over 9 minus 7. F of 9 is 5, f of 7 is 0 over 2. Okay, so that's the subinterval that we're going to use. Okay, so, yeah. So I'm going to say, all right, so first I'll show this in my explanation. Explanation. All right, and when you're doing your own, guys, you could just follow this template there. But the explanation is going to go like this. First, I'm going to state for my reader what I found off to the side. I'm bringing it into my explanation. Okay. And now I'm going to launch into the mean value theorem. Okay. Now, in order to use the mean value theorem on this subinterval, I need to establish two things about it. That H is, oh my gosh, I keep using F. I'm so sorry. Oh, guys. Oh my gosh. That is so bad. Okay. So I need to establish two things. That H is continuous on this interval and differentiable on the open interval. Okay, so, all right. And since it's a subinterval of 0 to 9, and they already told us it was continuous and differentiable, then we can say, that it also is on the subinterval. The H also is on the subinterval. Okay, so since H is continuous on 0 to 9, and you can say diff for differentiable, and differentiable on 0 to 9, it is also continuous on the subinterval 7 to 9 and differentiable on the open interval 7 to 9. Okay, so right there are the conditions for the mean value theorem. So now I can say, therefore, by the mean value theorem, there exists a C between 7 and 9 for which H prime of C equals 5/2. Okay, and now I got it. But they asked me to explain that there exists this C on 0 to 9. So I'll just be like, thus. Now I already established that 7 to 9 was a subinterval. Okay, so you could say it again if you want. You could say, thus, because 7 to 9 is a subinterval of 0 to 9. You could say that if you want, but it's okay. We already said it was a subinterval. So thus, there exists a C between 0 and 9 for which H prime of C is 5/2. Now, guys, it seems like, I don't know, if I was doing this on my own, so I wanted to teach it this way, but if I was doing this on my own, I would probably be like, instead of this one where I'm like, thus, there exists a C, I would probably say something like this. I'd probably say something like, this C must also, this C also exists on 0 to 9, because 7 to 9 is a subinterval, or something like that. I probably would word it a little differently. But anyway, so you can use your judgment, but you need to, all of this logic. You could use your language, experiment with like the flow of your words, but all of this logic needs to be included. Alrighty, guys, I'll talk to you later.